Welcome to GetX AML. Today we'll understand in this video the concept of rank of a matrix. This helps us in solving many problems. What is a rank? We already understood the row space and column space and how to find it using row echelon form and column echelon form or column echelon form. What is rank? How we define? The rank of a matrix A is the dimension of its row space or equivalent to its column space. So first you have to find the row space and then count the number of vectors in that. The dimension of a row space means what? Row space dimension means row space contains set of row vectors or column vectors. The count of those such vectors is the dimension of that row space or column space. So row space, that is rank, is equal to rank of matrix A is equal to dimensions of row space of A, that will be always equal to column space of A. Okay. So what is in the row echelon form of A? So number of pivot elements will give you this the dimension, right? How many vectors? That is the rank of A. So let us take example. So find the rank of this matrix. So first convert it into row echelon form. So how to make it? So make these two elements, try to make them 0. Okay, let us take R2 is R2 minus 4 R1. So the resultant matrix will be 1, 2, 3, 0, 5 minus 4, 8 is minus 3, then minus 6, 6 minus 12, right? 6 minus 6, and then this is 7, 8, 9. Now, so this is minus 3, I have to make it as 1, try to match this, okay? So it's possible. So now, what we will do, R2 is equal to minus R2, to change the sign, divided by 3. So I'll get it as 1. So this is 1, 2, 3, 0. This becomes 1. This becomes 2. This is 7, 8, 9. Now, the element below this pivot should be 0. So I cannot make it 0 from this row because it is 0 here already. So for that, what we will do, try to reduce it from row 1. So that is row 3 is, how will I get this? R3 minus 7 R1. So the resultant matrix is 1, 2, 3, 0, 1, 2. Then this becomes 0. Then minus 7 R1 minus 14, 8 minus 14 minus 6, and then this is 21 minus 21. So 9 minus 21 is minus 12. Okay. Now, so if you observe here, if I multiply 6, I can reduce this rows here to zeros. So what I will do, next R3 is R3 plus 1 into 6 into R1. Okay. Else you can divide this by minus 6, you will get the same thing. Can perform any operation to get that. So what I mean to say is, I can do it as R3 is minus R3 by 6. So I get 1, 2 only. So 1, 2, 3. So 0, 1, 2, 0, 1, 2. Or if I do this, I'll get directly 0. So get 0 here. So what is the row space in this row echelon form? Row space is equal to have these two rows independent. So this is 1, 2, 3 and 0, 1, 2, because I cannot further reduce it. Now this is equal to, what is the dimension of A? dimension of row space of A is how many vectors are there? 2 vectors are there. So that is equal to 2. So therefore rank of A is equal to 2. Okay. So basically our rank says how many pivot elements are there in the final row echelon form. Next, one more example. So it is a 2 cross 3 matrix. Use the row echelon form, okay, to reduce this matrix. So to observe here, to make it 0, multiply it by -2. So R2 is equal to R2 minus 2 R1. This becomes 1, 2, 3, 0, 0, and 0. So there is only one linearly independent vector, row vector, that is. So rank of this will be, rank of A will be 1, only one pivot element. Okay. So now we'll learn about some important properties of rank. So if you know these properties, you can solve many problems easily. Okay. So just I'll read out and then one by one we'll take and solve the example. The rank of A is less than or equal to minimum of m con n. So if there is a matrix, okay, of size m cross n, so m means number of rows, number of columns. So rank of any matrix will be less than or equal to, this is important, not equal to, less than or equal to minimum of these two. For example, if 3 cross 2, then minimum of 3, 2 is 2. So it will be always less than or equal to 2 for this matrix rank value. Okay. Next, rank of A equal to rank of A transform of that matrix. Rank of AB equal to less than or equal to minimum of rank of A separately from a rank of B. So to take rank of AB, then take rank of A and rank of B. So minimum of these two, okay, that, and the rank of AB will be less than minimum of these two. That is the meaning. If A is invertible, that means it's a non-singular. That means if you can find a inverse, that also tells you the determinant is not 0. In that matrix, the rank will be always equal to n, because for it to be invertible, it should be a square matrix n cross n. So it will be equal to n, okay, not less than or equal to. It's only equal to n. So removing zeros or rows or columns does not change the rank, which comes from your row echelon form. So rank of A plus B is less than or equal to rank of A plus rank of B. For any triangular or diagonal matrix A, rank is equal to number of non-zero diagonal entries. Okay, for both, it applies for both triangular, upper triangular or lower triangular, or if it is a diagonal element, diagonal matrix, then the rank will be equal to number of non-zero diagonal entries. Okay, the count I am saying, so not the sum. Trace is the sum, but count how many non-zero diagonal entries are there. That gives you the rank of that matrix. So elementary operation does not change the rank. In row echelon form, you convert it. Elementary operation change, subtraction, division. That will not change the rank of the matrix. Let us take this example. So for any m cross n matrix A, the rank will be less than or equal to minimum of the order of the matrix. Okay, so for A equal to 1, 2, 3, so try to convert it to row echelon form. So row echelon form, try to make it 0. If I try to make it 0, this will become R2 is R2 minus 4 R1. Resultant matrix is 1, 2, 3. This is 0, minus 3, and then it is minus 6. So this then change the sign, divided by, that is R2 is minus R3 by 3. So this becomes 1, 2, 3, 0, 1, 2. I cannot further reduce this matrix. Okay. So this is the in the row echelon form. So what is the rank of this matrix? So there are no zero matrix, so rank will be equal to 2. That is minimum of, is the order of this matrix 2 cross 3. So this will be less than or equal to 2. So that is verified. Next. For any matrix A, rank of A equal to rank of A transpose. So now we have taken the transform of that previous matrix A. So it was 1, 2, 3. No, we have taken different matrix. Let us say this. We'll solve, find the rank of this matrix A. So rank of this Fourier form, first take the echelon form, row echelon form, REF. Now try to make this 0. So that is R2 is R2 minus 3 R1. So this becomes 1, 2, 0, 0, 4, 8. Now try to make this 0. Is R3 is R3 minus 4 R1. So this is 1, 2, 0, 0. Then this becomes 0, 0. The rank of this matrix is, so only one linear independent row. So rank of this matrix is, rank of A is equal to 1. Now, if I take the transform of this, it becomes A equal to, rows becomes columns 1, 3, 4. Then 2, 6, 8. So it is now easy, right? So I can take R2 is equal to R2 minus 2 R1. So resultant matrix A will be in row echelon form. So 1, 3, 4. This will be 0, 0, and 0. So rank of this matrix is A transform is equal to 1. So it verifies your property. Next, for two matrices A and B, rank of AB is less than or equal to minimum of rank of A, comma rank of B. So first let us find AB. AB will be 1 into 2 plus 2 into 1, that is 4. Then 1 into 1 plus 1, 2 into 1, that is 3. Then 1, 2 plus 1, 3. 1, 1, 2. This is AB. AB already given. So let us find rank of AB for this matrix. What is the rank of this matrix? Rank, if I reduce this also, if I convert it to row echelon form, so if I convert this and make it 0 also, this cannot be made 0. So the rank will be AB is 2 only. Then rank of A. Rank of A converted to row echelon form. So if you subtract this, it becomes 0. This becomes minus 1. So that is the end. So again, we don't have any 0 rows. So rank will be 2 only. Then rank of this is again 2. So what is that say? Minimum of 2 comma 2. So 2 rank of AB is less than or equal to min of 2 comma 2, that is 2 only. So 2 is less than 2 equal to 2, verified. Next. If A is an invertible n cross n matrix, then rank of A is equal to n. So how will you find it is invertible, non-singular? Determinant of A not be equal to 0. So determinant of this is 6 minus 5 equal to 1. So it is not equal to 0. Hence it is invertible. Now the matrix n, the order of the matrix is n. So it's n cross n matrix or 2 cross 2. So rank will be 2. That's what they are saying. Let us check the rank of this. So rank of A is equal to, so convert it into row echelon form. So it becomes REF of this will be 2, 1, okay, 0. So that is you subtracting minus R2 is R2 minus 2.5 into R1. 2.5 minus 0.5, I cannot further reduce it. So rank is equal to 2. So that is the order of the matrix. Next, if A has 0 row or column, removing it does not change the rank. So we already seen in row echelon form. So anyhow, if I remove this 0 matrix and then find the rank, it will remain same. Including this also, it will be same. You can check it. For two matrices A and B, rank of A plus B is less than or equal to rank of A plus rank of B. So A plus B is what? 1, 0, 0, 1. So it is already in row echelon form, so you cannot further reduce it. The rank of A plus B is equal to 2. This is the rank of this matrix here. It's already in row echelon form. Okay. So rank of A is equal to 1. Now convert it into row echelon form. So it becomes, just swap the in or interchange the rows from 0. Now it's in REF. Okay. The rank of this is 1. So total rank is 2 of A plus B. Be less than or equal to 1 plus 1. So 2 is less than or equal to 2. Verified. If A is triangular or diagonal, rank of A equal to number of non-zero diagonal entries. Let us take this example. This is a triangular matrix because below diagonal elements all the elements are 0. So rank of this, so already check if it is in row echelon form. Not there. So convert this and then so how will you make this? So 5 divided by 2.5, I will get 2. So this will be still there. So that means there will be 2 independent rows. So rank of A will be equal to 2. So what is that says? The number of non-zero diagonal entries. How many non-zero diagonal entries are there? So 2, 5, 0. 2 is non-zero, 5 is non-zero. This is 0. So rank will be 2. So directly you can write rank equal to 2. That verifies the property. Similarly, if it is a diagonal matrix, already it's in row echelon form. I cannot change anything here. Okay. So what is the rank of this matrix is 2. So R of B is 2. Again, according to property, number of non-zero diagonal entries, that is 2, 5. Okay, number count, that is 2. That is verified. Next, elementary row or column operations do not change the rank of the matrix. So when you convert it into row echelon form or column echelon form, so you already seen it doesn't affect. So if I change these values, so try to convert this to 0. So let us say, so this is 1, 2. Let me make it as R2 is R2 minus 3R1. 2 minus 3R1. So I convert this, it will become 0, 0. So rank of this is 1. Okay. Rank of this is 1 linear independent row available. So after changing this, okay, it doesn't change my rank of the matrix. So if I change the minus, I'll change the signs of this. Okay, but still I'll get the same rank. That is the meaning. Elementary operation, if I perform any elementary operation, that is changing the sign, addition, subtraction, multiplication, division, the rank will remain same. Next, what is nullity of a matrix? So we already seen how to find the null space. Okay, row space or column space gives you the, helps us to give the rank of a matrix. What is nullity will be used? Nullity of a matrix is the dimension of its null space. It represents the number of free variables in the solution Ax equal to 0. So when you find out the null space, when you found out the null space, so you represented any rows with zeros as free variables. So that actually defines the how many such free variables are there. That gives you the nullity of a matrix, the number of or the dimension of the null space. So how will you find the nullity of the matrix? So first convert it to REF. Now R2 should be R2 minus 2R1. The resultant matrix is 1, 2, 3, 0, 0, 0. The rank is 1. Now how many free variables are here? Okay, see, this is 2 cross 3 matrix. 2 cross 3 matrix. Now, what is the nullity? So, first is x1 plus 2 plus x3 is equal to 0. Oh, sorry, 2x2 plus 3x3. Now, what are the free variables here? Free variables, there are 2 free variables here, x2. Let us put it as t. x3, let us put it as s, some other variable. Then you solve the equation because there are 2 free variables. Total dimension is m cross n. So 3. Out of 3, only 1 row I am getting, that is the meaning. So one free variable we have. So x2 equal to t and x3 equal to s. Let us put. That means what? You will have solution x1, x. So which are the free variables? These two are the free variables. You need not solve it also. Free variables, 2 variables. So nullity of this matrix is null space A. You can write it, but nullity of matrix is dimension of nullity of A. Okay. So that will be equal to 2. Next, Rank-Nullity Theorem. For any matrix A in the real domain with m cross n size, okay, m is the number of rows, n is the number of column. Rank of A plus nullity of A is equal to n always. It is equal to number of columns. That is the reason I took here the number of columns to calculate the free variables. So this shows the balance between the pivot variables and free variables. The two things you are found out in for row space, column space, and null space. To identify the pivot element, and this pivot element gives you number of pivot element gives you the rank, and number of free variables gives you the nullity. If I add those two, I should get n. That is the rank nullity theorem. In the previous example, the same example, you got rank of A is equal to 1. In the rank of, nullity of A is equal to 2. Okay. So that should be, what is the order of this matrix? 2 cross 3. So sum of these two will be 3. So RA plus R, nullity of A should be equal to 3. So 1 plus 2 is equal to 3. That verifies the rank nullity theorem. So in the next video, we will solve many problems on this concept. So far you have learned on the rank, column space and null space. Thank you for watching. Please like, subscribe and share.